Welcome again. This is Algebra 1, Mr. Hinton's pod number 2, section 10.3 out of our Holt Algebra 1 book. This has to do with data distributions. Our objectives here, we're going to describe the center of a data distribution, and we're going to be able to create a box and whisker plot. Vocabulary, some terms we need to know. Some of these you probably already know. Mean, median, mode, range, maximum, and minimum. Some others are outlier, quartiles, interquartile range, or IQR, and box and whisker plot. So we need to know what each of those terms mean. All right, mean, median, and mode are called measures of central tendency, or simply just measures of center. To find the mean, well, wait a minute, they tell us about the middle or the center of the data set. Okay, to find the mean, another word for mean is average, and what you do is you add up all the data values and divide by how many there are. Find the sum of the data values divided by the number of the data values. To find the median, you get the data in order, and then you find the middle value. Now, if there are an even number of data items, when you get them in order, there's not a single item that's the middle one. There will be a middle two. So to find the median, you find the mean or the average of those middle two values. And then the mode is the value that occurs most often. Note that there could be more than one mode if there's ties, or there might not be any mode at all if none of them repeat. Mean, median, and mode. All right, maximum, max is the maximum data value, min is the minimum data value. That's pretty straightforward. And then to find the range, you subtract those. In other words, how far is it from the maximum to the minimum? Take max minus min, that's your range. Okay, for example 1, we want to find the mean, median, mode, max, min, and range of this data set. So we have a lot of things. 1, 2, 3, 4, 5, 6 things we're going to find here. First one is the mean. To find the mean, again, we need to know how many data values there are. If you count, there are 11 of those values there. We need to add them all up. So we add all those up, we get 286. We take 286, divide that sum by 11, and we get 26. Therefore, the mean is 26. The median, we have to get the data in order. So notice that I've put the data in order for you here. And then we have to find the middle two numbers. Find the middle number of this set, not the middle two numbers, the middle number of this set by counting in from the ends the same number of numbers. So, a 16 and a 36, and then the 20 and the 33. The 21 and the 31, 24, 29, 24 and 27, that leaves 25 as the middle number, therefore the median is 25. To find the mode, you look and see which one repeats. Well, when you get them in order, you can see, okay, there's a 24 and a 24 here. The 24 shows up twice, none of the other numbers repeat, therefore the mode is 24. The range is maximum minus minimum. The biggest number is 36. The smallest number is 16. 36 minus 16 is 20. So the range is 20. There we go. Now this might be new. Quartiles and interquartile range. The word quartiles possibly reminds you of the word quarter. And a quarter is 1/4 of a dollar. Or a quarter in a basketball game is 1/4 of the basketball game. The quartiles then, along with the median, divide the data set into quarters or fourths. So how do you find it? Well, to find the quartiles, you first must find the median. Now the median divides the data into two parts. So there's a lower half and there's an upper half. To find the first quartile, you find the median of the lower half. Okay, now wait a minute. We found the median. That divides it into a lower half and the upper half. So then you're only looking at the lower half. You find the median of that, and that is your first quartile. Then you only look at the upper half, and you find the median of the upper half. That is your third quartile. First quartile, third quartile. Wait a minute, where's the second quartile? Well, we already have the second quartile. Can you guess what it is? Some of you probably already know. The median is the second quartile, but we don't call it second quartile. We call it the median. So the first quartile, the median, and the third quartile. Divide the data up into fourths. All right. So now, still on quartiles, and now we're going to talk about an interquartile range. Once you have the quartiles, you find the IQR, or interquartile range, by simply subtracting the two quartiles. We already have something just called the range by itself, where you subtract the maximum minus the minimum. That's range. The interquartile range is the same thing, but it's from one quartile to the next quartile. So all you do is subtract the quartiles. Suppose you have a first quartile of 45, third quartile of 89. You can find the IQR by taking the 89 minus 45, so your IQR there would be a 44. The IQR, again, is a range, but instead of the range of the entire set, it is the range between the quartiles. Example 2. Okay, they want us to find the mean, median, mode, range, quartiles, and IQR of the following data set. So we got all these data items. Notice there's 4 rows of 4, so there's 16 of them there. Well, again, to find the mean, you add up the values. The sum of those values is 399. You divide by how many there are. That's 16. So your mean, 399 divided by 16, your mean is 24.9375. Find the median, we put the numbers in order. Notice I got them in order, and I start counting in from the ends, get the same number, and there's an even number of data items, so there's not a single middle one. There's 2 of them. So the median is the mean of these 2, or the average of these 2. So your median is going to be 25.5. We would add 25 plus 26 and divide by 2. The median then is 25.5. The mode is the value that occurs most often. Okay, you start looking through this data. Oh, here, there's 2 24s right there, but we go on, there's also 2 29s. Those are the only ones that repeat. And so it's a tie, so there are 2 modes. The mode is 24 and 29. That's sometimes called bimodal. They both show up twice, all the other numbers just show up once. The range is max, 36, minus minimum, 13. 36 minus 13 is 23. The range is 23. Okay, we have the median. The median divides the data into 2 parts, the lower half and the upper half. Just looking at the lower half, we can find the first quartile. So just looking at these, we find the median of these 2. So we start moving in from this side, and we move in from this side. If we come in 3 from this side, that gets rid of those first 3. We come in 3 from this side, gets rid of those, and that leaves a 20 and a 22. You find the mean of those 2. The mean of 20 and 22 is 21, so the first quartile is 21. Now we're going to do the same thing with the upper half. We're going to find the median of the upper half, and it ends up being 29 and 29, which the mean of those 2 is 29. Third quartile is 29. Once you have the quartiles, you can find the IQR, the interquartile range, by subtracting. We take 29 minus 21. The IQR is 8. Next up are box and whisker plots. A box and whisker plot is a type of a graph that is done on the number line. To make one, you need 5 things here. You need to get the data in order, and then find the minimum, the maximum, the median, the first quartile, and the third quartile. Again, 5 things. Max and min, the median, the 2 quartiles. All right. You begin by making a number line that covers or includes the minimum and maximum values. So those values, on the number line, they should be uniform, which means they're the same distance apart. Then what you're going to do is make vertical lines above the number line where the first quartile, the median, and the third quartile are. You'll make vertical lines above these 3 things on your number line. Then you're going to use the first quartile and third quartile lines, and you're going to make a rectangle out of those, or a box out of them. Those lines above the first quartile and third quartile will be the sides of the box. Then you make the top and the bottom, and notice that it should have the median line inside of it. Here, from the sides of the box, you're going to draw horizontal lines to the max and the min. The left side of the box should have a line that extends to the minimum. The right side should have a line that extends to the maximum. These are the whiskers. So remember that we have box and whisker plot. Let's see how we could do this. Take an example. Let's make a box and whisker plot with the following data. So these are the 5 things we need. Minimum and maximum, the median, the first quartile, and the third quartile. So we've either figured that out or somebody's figured it out for us, but we have those things. From that, we can do the box and whisker plot. I'll make a number line that begins at 20 and goes through 60. The minimum is 23. The maximum is 58. So those are included if I go from 20 to 60 with values at every 5 numbers. Okay, now see, this is what I mean by the values on the number line are uniform. They're the same distance apart. Okay, now we will put our vertical lines in at the first quartile, the median, and the third quartile. There's my first quartile. First quartile was 28. So at 28, I put a vertical line. Now I'm going to go with the median. My median was 32. So at 32, I put another vertical line. And my third quartile is 38. So I put another vertical line here. Now I'm going to use these, and I'm going to put a box around this, using the parts at the first and third quartile as the sides of the box. There's the box. Now I draw the whiskers. We extend our whiskers out to the minimum and maximum. That's going to the minimum. My maximum is 58, so I put a line out here to 58. Okay. Note that this box, the box itself, half of the data, 50% of the data is in the box. This left-hand whisker is the bottom 25% of the data. This whisker is the upper 25% of the data. And I can even tell where the middle of the data is. That part of the box only is 25%. Here's 25%. Lots you can tell from a box and whisker plot. Outliers. An outlier is a data value that is very much unlike the other data values. Okay, look at the following data set and decide what the outlier would be. Note that the data, I've already put the data in order for you. So what's the outlier? You start looking at these numbers as you go through. And it's like, whoa. All these numbers are between 24 and 30, except for 145 is way out there. The outlier would be 145. Every other number is between 24 and 30. They're very similar and close together, and then 145. It's very different from the other data values. It's the outlier. Okay, choosing a measure of central tendency. In other words, which is better, the mean or the median? In general, under normal circumstances, the mean is a very good measure of center of the data set, but there's some situations where the mean is not as good a measure. And for instance, let's take a look at that last set of data. Look at this. Now remember, we have this outlier in here. If we find the mean of this data, the mean of this data is 36.2 or something real close to 36.2. Well, most of this data is between 24 and 30. But the mean is 36.2, which puts it above most of it. It puts it out in here. So we don't feel like that is that good of a measure of the center of the data. In this case, a median is a much better measure of center because this outlier really affects the mean a lot. It doesn't affect the median. The median's still going to be right in the middle somewhere in here. Okay? And that's it for now. So thanks for your attention. Goodbye.